Alrighty. So we're on the first set of notes for Unit 7. These set of notes are actually kind of short. They're introducing ideas that are going to be explored in the next two sets of notes. Um, there's a big table on the back of these notes that we're actually not going to go over this time. I can walk them through in person if you'd like, but because they're covered in the next two sets of notes, um, you'll be able to fill that out yourself as you go through the next several steps. So really what I'm going to make sure we cover in these notes today is the definitions you'll need and also naming all of the polygons. So we're only going to go through the first page front and back. So let's go ahead and start with our definitions and go from there. A polygon is a closed figure in a plane. Now that plane is going to be a flat surface, a 2D space. Okay, so that polygon is going to be made of 3 or more sides. Cannot have a polygon with 2 sides or less. It's made up of straight segments. And those segments are connected at endpoints. Okay. So I'm going to start with examples of non-polygons. This thing is not a polygon because it's not closed. This thing is not a polygon because it is made up of stuff that is not straight segments. It has a curve in it. And this sort of hourglass shape is not a polygon because its segments connect at something other than endpoints. This one's actually 2 triangles stuck together. So by comparison, polygons are nice, even, orderly shapes. I have like a square, a triangle, a pentagon's fine. All of those are polygons. Okay, the next definition involves convexity. So we're going to start with non-convex. This guy here is going to be non-convex. This guy here is going to be non-convex. Another word we can use for non-convexity is concave. And all of these shapes are concave because they have cave-ins. So we have like a little dent going into the shape. You're going inwards, so you're concave, you're going in, caving in. I'll do one more concave shape. And so because it has that dent inwards, it's a concave shape. So convex shapes, on the other hand, don't have a dent. They don't have a dent. It's sort of outward facing at all angles. So like a square is convex, a triangle is convex. This pentagon is convex because none of its angles point in. No angles point in. So our convex polygons can further be regular. Okay, so a convex polygon is a regular polygon where all of its sides and angles are equal. Okay, so if all of its sides and angles are equal, that's like your equilateral triangle. All 3 angles and all 3 sides are equal. A square is regular. And let's say like a regular pentagon, it's going to have 1, 2, 3, 4, 5 congruent sides and 5 congruent angles. Okay, that's compared to irregular polygons like this rectangle. All of its angles might be the same, but all of its sides are not. This obtuse triangle. We'd also have just a weird thing like that. None of these are regular. Okay, so with those established, let's go ahead and talk about our different names. Looking at this chart, we should already know the first few. A 3-sided shape is a triangle. If it's got 4 sides, you might want to call it square. It's actually a quadrilateral. A 5 is pentagon. 6 is hexagon. 7 is heptagon, H-E-P, tagon. 8 is octagon. 9, nonagon. 10 is decagon. 12 is going to be our dodecagon. Do in this case means dose. Dose for 2. So the do in dodecagon is dose. Then we move up to our 20gon. So once we get past 12, we're going to stop naming them special names. We're just going to go with 20gon. Okay? Same for 50. We have a 50gon. For an unknown number of sides, unknown or any, we have an n-gon. So, if you want to figure out the number of sides later on, you would call it an n-gon. A 31-sided shape would be a 31-gon, and so on. So, like I said, this is a relatively short piece of notes. That table on the back, we can work on it together, but you should also be able to fill it out based on the formulas you're going to learn in the next 2 parts. So, let me know if you have any questions, and thank you very much.